folks, let's go ahead and take a look at example 4. So this, I'm going to decompose this rational expression, and I'm being told it's repeated linear factors. So let's go ahead and take a look at what we got here and see if we can break down this denominator. That's where I'm going to start. So if I look at that denominator, I'm going to leave my numerator alone for right now. I can see a GCF of x. So I'm going to factor out the x, and I'm going to get x squared minus 4x plus 4. And maybe you recognize that as a perfect square trinomial, maybe you don't. But if I want to break this down a little bit more, let me make sure we can see all of this. We can still see my work. Great. All right, so I have this x, and I was hinted at that I've got linear factors, and I've actually been hinted even more than that I have repeated linear factors. But I want to think of two numbers that multiply to positive 4 and add to negative 4, right? Because I know I'm going to have x and x here. They're linear. But two numbers that multiply to positive 4 but add to negative 4 are negative 2 and negative 2. And there you can see my repeated linear factor of x minus 2. So if I want to clean this up a little bit, I have negative x squared plus 2x plus 4. And in this denominator, I have x minus 2 squared. All right, so if I want to start to decompose these fractions, what I essentially want to do is I want to take my original expression, or at least my original numerator. Oh, and just take note, your degree in your numerator is less than the degree in your denominator, so this partial fractions decomposition will work. All right, here we go. I've got linear factors. This is x to the first power, right? This is x minus 2, but still x to the first power here. I get that the binomial itself is squared, but the factor, the stuff inside the parentheses, is linear. So what I need to do is I need to have a fraction represent the x. I need a fraction for the first power of x minus 2, and then I need another fraction for the second power of x minus 2. That's how we start to get partial fraction decomposition to work. That's the mechanics of it. And again, I'm going to knock out the fractions by multiplying by my LCD of x minus 2 squared. And I'm going to multiply that LCD to the left side, and I'm going to distribute to each term on the right side. So it's going to take me a minute to write all of that out. So here we go. I'm going to multiply that LCD through, and then by design, I will knock out those fractions. And I mentioned this way back in example 2. I think eventually when you do this enough, you might skip this step. But don't skip it if it winds up affecting your algebra, right? No shame in doing this the whole way out. All right. There we go. So I've got all of that. Let's see what cancels. So the x and x are going to go. X minus 2 squared, x minus 2 squared. The x and x go. All right, the x minus 2 cancels with one power of that. Both powers of x minus 2 cancel with both powers of that. So let me just collect up what I have left. So on the left side, I have negative x squared plus 2x plus 4. On the right side, I have a times x minus 2 squared plus bx, x minus 2 plus cx. Now there's a couple of ways I can go about doing this, and I'm going to do both of them for you. So I'm going to do the system of equations first, and I would argue this is probably going to be the longer method. All right, so I'm going to tell you personally, I don't know if I would do it this way, but I want to show it to you because for some folks this method's going to work better. So let me scooch this up so that we can start to pick this apart. So what I have to do is distribute all of this. So we've got negative x squared plus 2x plus 4 equaling a. All right, x minus 2 squared is x squared minus 4x plus 4. And I've got bx squared from bx times x minus 2bx plus cx. Now I got to distribute here. So if I distribute that a, I've got ax squared minus 4ax plus 4a plus bx squared minus 2bx plus cx. So it's a lot to manage, right? So like I said, I want to show you this method. I don't know that I would use this. I would probably go with the plug-in x values way, but this is still totally valid. So we're going to line up terms, quadratic terms to quadratic terms, linear terms to linear terms, constants to constants. So as I do this, I see a negative x squared on the left, ax squared and bx squared on the right. So I have an equation. I know a plus b has to equal -1. That's my first equation. Oh, let me scoot this up. Like I said, we're gonna have a lot of stuff for writing here. All right, linear, 2x, what do we got? -4ax, -2bx. So I know -4a minus 2b has to be equal. Oh, JK, sorry, I just saw I have another linear term. I almost skipped that one. All right, so really -4a minus 2b plus c has to be equal to +2. So let me write that out. I've got -4a minus 2b plus c has to be equal to +2. And then for the constants, I have a 4. Oh, this is nice. And I just have a 4a. That actually makes my life a little easier. So I have 4a has to be equal to 4. That's going to help me. This is a nice happy accident. Sometimes this doesn't happen. And this system of equations is that much more convoluted. But here, if 4a is equal to 4, a is going to be 1. So I've solved one of my constants. And then I'm going to plug a equaling 1 back into this first equation because I can solve directly for b, right? If a is 1, then I'm going to know that 1 plus b is equal to -1. And if I move that 1 over, right, I'm going to get that b is -2. So there's my second constant. That's great. I've knocked 2 out of the 3. Now I'm going to plug in a being 1, b being -2, and then I'm going to solve for whatever c is equal to. So let's see what we have. We have -4 times 1, which would be -4. Okay, minus 2 times -2 plus c equaling 2. So I have -4 plus 4 plus c equaling 2. These are going to cancel and I get c equaling 2. So now I actually know my end game answer. I know I have 1 over x minus 2 over x minus 2 plus 2 over x minus 2 squared. So let me scooch this up, all right? And then I just gotta worry, sometimes my camera goes out of focus. So this ultimately means my original fraction of -x squared plus 2x plus 4 over x cubed minus 4x squared plus 4x ultimately decomposed into a over x plus -2, but b over x minus 2 plus c over x minus 2 squared, right? So great, fantastic, we've got that. Now what I want to take us through, and I might need to scooch this back down just a wee bit. I want to go to this equation here. Let's say I went from this step and I didn't go multiply everything out. So I'm going to put a little separation and I'm going to rewrite this equation and just show you an alternate way to get a, b, and c. So let's try -x squared plus 2x plus 4 equaling a times x minus 2 squared plus bx times x minus 2 plus cx. Okay, so let's just say we had this and I want to use the plug-in method. I'm going to pick specific values of x. Like I'm going to pick x equaling 2. So let me let x equal 2 and see what I get here. All right, so if x is 2, all right, so on the left side I will have -2 squared plus 2 times 2, which is 4, plus another 4. And we'll solve that in a moment. All right, if x is 2, 2 minus 2 is 0, so this term's going to go away. Here, 2 minus 2 is also 0. That term's going to go away, but this is going to leave me with a 2c. All right, so -2 squared is -4. -4 plus 4 cancels. So this is going to simplify to 2c equaling 4 or c equaling 2. And that's consistent with what we got up here, right? So it's just, again, it's another way to do it. If I let x equal 0, right? If x is 0, the only thing that survives on the left side is 4. All right, cx zeroes out, bx zeroes out, and then 0 minus 2, -2, -2 squared, +4. I'm going to get 4a, and then I'm going to get a equaling 1 from that, okay? And then you can let x equal anything else you want. I'm going to go with x equaling 1, right? Pick any number. If I plug 1 in, then on the left side I get -1 plus 2 plus 4, which is 5, right? -1 plus 6 is 5. If I plug 1 in, I get 1 minus 2, -1, -1 squared, +1. This is going to be a. B times 1 times -1 is going to be a minus b. right? C times 1 is going to be C. And when I substitute in my values here, right, we have 5 equaling, all right, A was 1. I don't know what B is. And then I know C is 2. And when I solve that equation, right, I get a 3 on this side, move it over, all the things, you're going to find out B is negative 2. All right, so that's just an alternate way to do it, okay? Thanks, everyone. Take care. Bye.